Question 5b. It says a tank has a cross section with dimensions identical to the polygon EFGHIJ in figure in 5a, in part 5a. So let us just take a glance back up. It says to the nearest whole number it is 65 centimeters square. Right, this was it. Each side 5 centimeters. Let's just jot that down because we might need it. So each side measured 5 centimeters, right? So there were 5 cm, and the area was 65 centimeters squared, the total area of the polygon. Now water is poured into the tank at a rate of 75 centimeters squared per second. So for every 1 second that pass, you have 75 centimeters squared. You have another 75 centimeters squared added. After 52 seconds, the tank is 2/3 full. Determine the capacity of the tank in meters, in liters. Alright, what you're going to consider, you have a time of t 52 seconds. Can we move up a bit, make more space under the figure? Alright, we have a little more space to work. So what you have here is a time of 52 seconds. T is equal to 52 seconds. 75 centimeter cube per second. So 1 second you have 75 centimeter cube. At 2 seconds you had another 75, which would be 50 centimeter cube, and so on. So that what you do to find, you can find the number of centimeter cubes that are added after 52 seconds. Alright, you're going to say whatever the volume of water is, that volume you calculate it by saying this 75 centimeters per second, because it means over second. If you multiply, because 1 second 75, 2 seconds another 75, which would be 150. So if you want to find the volume, you multiply that 2 by the 75. So you apply the same principle here. Multiply the time by 75. The more seconds that pass, the more water is in the container. So you multiply by seconds. It must be multiplied by 52 seconds. Notice also seconds would cancel up here, would cancel seconds down here, leaving centimeter cube. I didn't put the cube there. Always make sure to put the proper units. Seconds would cancel seconds, giving you volume. So here what you would have is 75. Let me put it in basic mode for now. It would be 75 multiplied by 52. 3,900 centimeter cube of water would go in there after 52 seconds, so 3900. Right? So what we have is 3900 cm cube. Now what can we do with this? Let's see. After 52 seconds the tank is 2/3 full. Okay, so what this means is that the 3900 is 2/3 of the total volume. Alright, so that's the volume. Let's call this volume 1. Let's not call it volume because we have different volumes to deal with. Call this volume 1. The first volume we find is 3900 centimeter cube. Good. Now it is 2/3 full. Determine the capacity of the tank. It didn't call it capacity, it called it volume. It's the same thing. But since it says determine the capacity of the tank, let's call what we want to find cap. So therefore, the 3900 centimeter cube is 2/3 of our cap, or capacity. You see that? 3900 is 2/3 of the capacity because it says here after 52 seconds it is 2/3 full. 2/3 of the capacity, the full capacity. Alright, so determine the capacity of the tank in liters. The capacity is 2/3 of the capacity now. So what do we do? If you consider this, let's rewrite it here. 3900 is 2/3 cap. If you divide by 2/3, 2/3 we cancel 2/3 and leave capacity alone. So capacity is, let's do it from right to left here. This divided by 2/3. What's 3900 divided by 2/3? It would be the same as 3900 times 3/2. Remember your fractions calculation. So the capacity is, and you could also do it with a calculator as well. So what you would do in that case is with 3900 divided by open bracket, if you're doing the division, 2/3 close bracket, equal, and you get 5850. If you do it this way, it would be 3900 multiplied by 3 divided by 2, and you get your 5850 again. So it would be 5850. That would be the full capacity of the tank, 5850 cm cube. So that would be the capacity of the tank in cm cube. They want liters. Remember now, 1000 cm cube make 1 liter. So when you convert this, if you say 1000 cm cube equal 1 liter, and you want cm cube to liter, what do? You want to turn 1000 cm cube into 1 liter. What do you do to turn 1000 into 1? You divide by 1000. When you divide 1000 by 1000, you get 1. So you do the same thing here. Divide the 5850 by 1000. So you get 5.85 liters. I didn't bother to write the other 0, but you could write it if you want. 5.850. I'll just write 5.85 liters. Alright? So let me just put it somewhere here. 5.85 liters. And that's the capacity of the tank. I just put it up there in case I need it later on. So let's just erase these and see. I wonder if I'm not sure if I would need the 3900 100, but let's keep it there for now. Now let's look at what it says further on. The height in meters of the tank. Okay, the height in meters of the tank. So here is 2/3. This is 2/3 the height at 52 seconds. What you could say is that if 2/3 the height is this, then you could compare what you had in liters before to what you have in liters now as one way of calculating it. So let's see what happens. How much larger is this than this? Remember, it's a regular polygon. Alright? It's a regular polygon. So if you say, oh, guess what? Let's not use that, because they did not give you the exact height at 2/3. You're going to have to use that area that you obtained before. Alright? Or that volume, I mean, that you obtained before. Now, what was the area of the polygon? If you remember that, then you could use the formula that the capacity, the volume, same thing. Let's use capacity, since they say capacity of the tank, they did not say volume of the tank, is equal to the area times the height, because it is a regular cylinder. It doesn't get wider or narrower as you go along the length of the cylinder. It's the same dimensions. So you could just say area times height. Now, what was the area again? Let's look back at what we did earlier. I'm looking back because I don't remember. I didn't write it down somewhere. So what was it again? It was here. Let me see if I could redo that calculation quickly. It was 60. It was 60 degrees in here. So the area of each triangle, and remember this was 5 and 5, half by 5 by 5 sine 60, and the total area was 6 times this. I remember that part. So it was 0.5 by 5 by 5 by oh, guess what? I remember that. Yeah, I kind of tried to remember. I kind of remember it was 65 or something, but let's use the figure before. It would be more accurate. Half by 5 by 5 by sine of 60 degrees, and then multiply that by 6 to get the total area. 64.95. Right, that refreshed my memory. 64.95. Alright, let's scroll back down. Or as this said, it was 65 to the nearest whole number. Alright, you could use the 65, no problem. Alright, could use the 65. as the area of this of the polygon. But let's use the 65, because many people might say, why bother with the 64.95? I could just use the 65. Alright, so the capacity, which is 5850, is equal to the area times the height. So 5850 is equal to 65 by the height. Alright, remember the area at the top here would be our 65 cm squared. So the capacity, being 5850 cm cube, is the area times the height. If you want height now, or let's say 55 times height is equal to 5850, and you want height alone, you divide by 65, cancel down, divide by 65. What do you get? Let's see. 5850 over 65 would be 90. Let me just see what the 5850 over the 64.95 would be. 90.069. Close enough. Alright, so the answer for this would be 90. Let me just write it down here. Oh, my equipment sometimes cause all sort of lines and dots to appear, but this would be 90 centimeters. And notice it's in centimeters because the 5850 was in centimeter cube. What am I doing? Centimeter cube up here divided by the 65 in centimeters squared. Centimeter cube over centimeter squared gives you centimeters, right? So this is kind of crowded though. So let me rewrite it here. So in this case, the height would be 5850 over 65, which would be 90 centimeters. So this is our answer to that part of the question. Alright, so let's scroll back down and see what it says. Calculate the height in meters of the tank, and you would use this part to do your calculation. So let's just erase all of this. Right, your calculation might look something like this, where you're looking at the height being 90 centimeters. It would be 5850 centimeter cube divided by 65 centimeters squared, which would be 90. So to clean it up, what you have in this case is the capacity 5850 is the area times 65. So when you divide both sides, the area it would be, the area is 65. It is the area that is 65. It would be the area 65 times height. Good. So what this is saying is that the volume is equal to area times height of a regular solid, right? Where the cross-sectional area is regular. If you want to use cross-sectional area, could use CSA as well, no problem. And then in this case, the height now, the height would be 5850 divided by 65, and that gave you what, 90. It was 90 centimeters. All right, it would be 90 centimeters. You could also put in the dimensions and say this is 5850 cm cube divided by 65 divided by 65 cm squared. You know, cm cube over cm squared gives you cm. So in this case it would be 90 cm. Cm cube over cm squared, it would be cm cubed would be cm by cm by cm over cm squared, which is cm by cm. Two of them would cancel and leave cm alone. So that's how this part works. Alright, let's see what else happens here later in the question. Well, when it says total marks, it means the question is finished. So question 5 is finished, and question 6 is what we will move on to later on. Alright, so let's look at question 6 a bit later.